We have seen in the last video about that electron gain enthalpy, wherein the del Heg value, that we write it down as del Heg, the value is always negative. Okay, why? Because when it gains electron, when a neutral atom, okay, when an isolated neutral atom, when it gains electron, it has to release some energy. Okay, that energy only we write it down. Energy is measured here. Okay, the del Heg is the energy only, is measured at constant temperature. We have, constant pressure. It is not temperature. We are measuring at a constant pressure only. So, okay, in that constant pressure, the Heg is always negative. When it gains electron, when it gains one electron, it becomes the X minus ion. So what happened? This is an anion, right? And it releases some energy. That energy is always comes to negative because releasing energy. At that time, it has to release energy. So what happened? That we are measuring that energy by kilojoules per mole, I said. Okay. Now we are going with the, when you are going to take one more electron. What happened? That is, when it is gaining successive electron, that is, it is going to gain one more electron. What would be the value? That is what we are going to see in this video. So usually we say, no, ionization energy 1, ionization energy 2, like that, no, like that. Here it is going to be 8 electron gain enthalpy 1, 2 and all. Okay, first of all, you need to know about what do you mean by this. Once it becomes a monovalent ion, remember this, children, when it becomes monovalent ion, anion, okay, this is anion, right? After it becomes that monovalent anion, there would be inside that atom, there would be the proton charge would be less. Yes or no? The proton charge is, now it becomes less than electrons, isn't it? Electron is gained already, so proton charge is less. When you go with that, naturally it happened. What happened to this? There would be less attraction. Okay, otherwise the attraction gets decreased. Okay, why? Because that proton charge has become more and there are electrons only more. Okay, proton charge has become less. Proton charge has become less when compared to that electron. So what happened? Naturally, the attraction charge. Why attraction has become decreased? Because it is going to gain electron. There would be repulsion only. So the nuclear charge, that usually we call it as nuclear charge, that nuclear charge upon that electron becomes less also, isn't it? The nuclear charge is also less. I can write like this, that is decreased. Okay, so nuclear charge decreased, that is because of that, the attraction is also decreased. Okay, naturally what happened? Why this is? Because again you could say there is repulsion, more of repulsion. That is, electron is going to, you are going to bring electron only, no? So there are more number of electron, no? So the electron repulsion becomes increased. Is it clear? So in this way the factors are there. If we are going with this concept only, we need to keep that in mind, how that second electron is going to be taken. See, if it is going to be taking that second electron, okay, if it's going to gain that second electron, I'm just coming with that monovalent anion itself. What happened? There is repulsion. I have written already, there is repulsion. Due to this, what happened? It has to overcome that repulsion. No, at that time we need to give some energy. It is not that it cannot release energy. So for that reason, we have to give energy. Let me write down in this way. So to overcome that, okay, to overcome the repulsion, I said there is repulsion only because electron is more and nuclear charge becomes less, and then electron repulsion is there. To overcome that repulsion, it needs energy. It needs energy. It cannot release energy. Instead, it needs energy. At that time, what happened? Naturally, the value become positive. Is it clear? So the del Heg value become positive for the second electron. That means, and what about the third electron? Again, it would be less only. That is, it's going to be more positive. It's not going to be negative at all hereafter. Okay, is it clear? So that when you go with the second electron onwards, the del Heg value becomes positive. I could say that del Heg value is positive if for second electron and even for third electron, like that it goes on. Is it clear? So this is what we have understood. Up to here we have understood. With this only we are going to move to what is that group 16. Let us take one example of group 16. Okay, with this we can go for that. What is that? Group 16 actually oxygen. Isn't it? Group 16 is oxygen. Is there at the top. That is oxygen atomic number is 8. How does it split? It usually splits as 2 and 6. We know that K shell, L shell, we have it has got 2 and 6. Okay, the electrons are 2 and 6. Now, first of all, what it does, it takes 1 electron. Okay, first it takes 1 electron. When it takes 1 electron, that is, it gains 1 electron, what happens? K shell will have 2 and L shell have 7. Okay, that means the proton here it is 6 only, but here the proton is 7. Okay. I'm sorry, proton is always 6 only. There is no change in the proton, right? So the proton is here also 6 only. So, but what happened? The electron becomes more because of the addition of 1 electron. It releases the energy and it gains that 1 electron and it becomes, so that LHEG value is negative for this case. That is, this is the first electron. Understand? This is the first electron gained. So what it become? It has become O minus now. First electron gained. Now it has to gain 1 more electron, isn't it? It needs 1 more electron. This one has to gain 1 more electron. It needs 1 electron. So I am writing in this way. Arrow mark, I am putting it on the other side. It needs 1 more electron to become K is equal to 2 and L is equal to 8. In that case only it becomes stable. At that time only it becomes stable, right? Now 8 electrons if it comes for that L shell, then it becomes stable. We know that, isn't it? So what happened? It needs 1 more electron to become stable. At that case, it cannot, there are more number of electrons, 7 electrons, but there is less proton, number of proton less. So there is a repulsion. That repulsion will be there. More number of electron, and that this electron cannot be gained by it. So for that, it needs some energy. So the energy has to be given. So we are giving energy only. So the energy, when it is given, what happened? The delta HEG value here, it is not going to be negative, instead positive. Okay, so the positive value means this is negative and this is positive. What happened? Positive, negative, and this is positive, and the value become less negative, isn't it? When you are adding up to this, that is the case. When you are going with that chlorine is taking only 1 electron. Chlorine needs only, because chlorine, let me go with the chlorine or fluorine, because fluorine is the next element. Fluorine, both are in the same group, right? Fluorine and chlorine both are in same group. So let us go with that same next element. What is that? Fluorine. Fluorine takes only K shell 2 electrons and L shell 7 electrons. It has to gain only 1 electron. When it gains 1 electron, it is going to be, del HEG value is going to be negative only. Okay, but here in this case, it is for first electron it is going to be negative. For the successive electron it is going to be positive. Naturally, the value becomes less. So the less negative value you get. That is the reason when you are going towards left, that is going towards the left of the periodic table, what happened? Naturally, the value becomes less, or else you could say less negative. Is it clear? So the successive electron gain enthalpy is not going to be positive. It's not going to be negative hereafter. It is going to be positive. For that reason only, you are getting that less negative charge while you are going down. Is it clear up to this? Now let us go with the, there is one example. There are some exemptions we need to go with. That exemptions are there found in the group. We have seen that down the group, the electron gain enthalpy usually decrease is set, but between that fluorine and chlorine there is increase. Okay, that electron gain enthalpy is increased. Why? Usually this trend is actually down the group, it is decreased. Electron gain enthalpy decreased. Children, what did I say? That we are going with the fluorine and chlorine, the del HEG value becomes coming more when you compare to fluorine and chlorine. Down the group it has to decrease, but between that fluorine and chlorine there is a anomaly behavior. What is that anomaly behavior? Why it is so? That we are going to see. Okay, that is what I have written down and I am going to show it to you. Right, you know that this is group 17. In this fluorine and chlorine, what happened? How they are arranged actually? The electrons are arranged in their shells 1s2, 2s2, 2p5. That is between that only in this K and L shell. But in case of this chlorine, 1s2, 17 electrons. So 1s2, 2s2, 2p6, 3s2, 3p5. they are arranging in all the three shells, that is KLM shells. Okay, KLM. In case of that fluorine, you have the size is smaller. But in say case of that chlorine, the size of the shell is bigger because made up of three shells. Here it is only two shells. And also you could see that second shell can occupy only 8 electrons, wherein in the third shell, M shell, can occupy 18 electrons. So here the nuclear charge, they are made up of two shells. So the nuclear charge is more, but the electron, and also the electron density is more. Here it is made up of three shells. Okay, so the nuclear charge is less only, and there are less electron density because it can accommodate, this third shell can accommodate 18 electrons. So it is easily, it can, that outer incoming electron can easily get into this. But here it is not possible because of that electron density. There is one more thing, there is more repulsion also for incoming electron. In such a case, we need to give more energy for that incoming electron to come inside, other than that releasing of energy. So positive value is also added up, so it becomes less negative value. But in this case, here it is bigger in size, nuclear charge is less repulsion. So what happened, del He value is negative with the more num value. Okay, is it clear? The same anomaly could be seen here also in case of group 16 among oxygen and sulfur. The same way you can explain in that same say small size in case of oxygen. Here that sulfur is the bigger size due to that same number of shells only. Here it is only K and L shell. Here it is KLM shells. Okay, and moreover that double shaped p orbitals, here it is lesser in that is smaller in size, here it is bigger in size. Okay, and then you can say that repulsion becomes more, electron electron repulsion is more, here it is less due to the density of electrons in case of oxygen is more. Okay, and here it is less. The third subshell, you can 18 electrons you can accommodate now, because of that it becomes less, so the repulsion becomes less. And so of these for all of these reasons, this sulfur is having more negative value. Okay, more negative enthalpy value. Okay, is it I think hope you have understood about this, children, why that anomaly what is found in electron gain enthalpy. Okay, and with this we are concluding this electron gain enthalpy. Last video I was talking about that electron gain enthalpy, how to go with values, and also here successive electron gain enthalpy we have seen, and what is that anomaly found in the among the groups, that group 16 and 17 we've gone with that. So if you have any other doubt, please put it in the comment box. Thank you.